Slope. What mysteries await us in today's section about lines? Well, first of all, the essential question is, how can I describe a line by using slope? And if you think about slope, it really makes sense in real-world contexts. We like to talk about how slanty things are, how steep things are, how not steep things are. For example, this skier is about to die. Why? Because this slope is way too steep for him. He's going to plunge to his death, and he will be lying there like this. Why? Because it was too steep. The slope is very steep. This hill, on the other hand, is more Mr. Gregory's level. This is called the Bunny Hill in America. And yeah, the Bunny Hill, even a bunny could ski on it. Look how shallow this is. Not steep at all. Although this little kid found a way to faceplant somehow. But in general, yes, very, very shallow. You can't crash unless you're this loser. Here's some more real-life examples. Let's think about riding a bike. We just talked about going downhill. What about if we're going uphill? Then you might be like this guy. Riding a bike uphill is very hard. It's usually actually easier just to get off and walk. This guy's chillin'. He's putting in some effort because he's on level ground. These guys are rocking it life. They are on the nice, smooth downhill. So whether something is uphill or level or downhill or even downhill by a little or a lot, this changes things for us, right? And that's how it works with lines. When you have lines, we care about how steep that line is. So here is what slope is. Let me give you the official definition. Slope is, and you've probably heard this before, it's rise over run. It's the ratio of how much a line rises to how much it runs. And if we take that ratio, it actually tells us about how steep the line is. Another way we can look at this is we can notice that rise is the change in y. Change in y. Run is the change in x. And remember, that's because change in y is the up and down variable in our Cartesian coordinate plane. X is our right and left variable in our Cartesian coordinate plane. So rise, y, over run, x. The last way we can write it is this, and this is a very useful formula. If we have 2 points, you can go y2 minus y1, subtract the y coordinates, see how much y is changing, over x2 minus x1, subtract the x coordinates, see how much the x is changing. People get confused about what this 2 and this 1 mean. Is that an exponent? How do I read it? You can read it as y sub 2 and y sub 1, and all it means is that this guy, this y sub 2, is the y from the second point. This guy, this y sub 1, is the y from the first point, but those little numbers don't affect the math. It's just a label. Also, we can talk about, hey, let's say I have a line that's going up. So as I'm reading from left to right, this line is going up. What kind of slope will it have? Well, this has a positive slope. Every single line that goes up from left to right has a positive slope. And you can probably imagine lines that go down from left to right, these falling lines, they have a negative slope. And think about what would happen if you were walking along this line, again, as you go from left to right. If you were a little dude walking along a line, going uphill, you'd be getting higher, right? You'd be going up, it's positive. If you were this guy skiing down this little slope, you'd be losing elevation, right? You'd be going negatively, you'd be getting lower. There are 2 other kinds of lines we talked about. There's a horizontal line. So think about a biker. He's on this line, he's chilling, he's riding. This is 0 slope. And I like to think this guy is putting in 0 effort right now. He's just not gaining or losing elevation. He's just staying level. He's not rising at all. He's just running 0 slope. Finally, a vertical line. This actually has an undefined slope, and we'll talk about what that means a little later on. You can think of if a guy was trying to walk along here, Think about how it is to walk along a wall, basically. He would fall and die. Bleh, he's dead because he fell off the undefined slope. So undefined, if you're trying to walk along it, it doesn't make sense. It's undefined, you fall off, you die. Let's do some examples. I've been talking about the theory a lot. Let's do some examples. Find the slope between of the line. That doesn't make sense. Let's just find the slope of the line. Okay, so what I said slope was rise over run. So what we can do is we can look at 2 points on this line and see how much this line rises and see how much it runs. So let's see, here's a point and here's a point. These points are right on the grid lines. It's not like this point that's kind of awkwardly in between. I know that this point for sure is -2, 1. I know that this point for sure is over 0, up 4. And if I want to find the slope between those 2 points, the slope of the line, I can say rise. How much am I going up? As compared with run, how much am I going over? Well, in this case, the rise is 3, right? I'm going up 3 places. The run is 2. Because I'm going over 2 places. So slope of this line, rise over run, is 3 over 2. And the whole line has that slope. If I go up 1, 2, 3 over 1, 2, I hit another point on the line. If I go up 1, 2, 3, 1, 2, I hit another point on the line. Rise over run. I can also use the formula. Remember we said that the formula was y2 minus y1 over x2 minus x1. I have 2 points here. I said that this point was -2, 1. I said that this point was 0, 4. I can use this formula first by labeling the points. So let's do, we'll call this point, point 1. And remember that this is the x, so I'll say x sub 1, since this is the x of the first point. This is y sub 1 because it's the y of the first point. We'll say that this point is point 2, so x2 and y2. Again, I'm just labeling things. Now that I've labeled, I can just plug right into my formula. So y2, what is it? Here it is, it's 4. Minus y1, what is it? Here we go, it is 1. Divided by x2, where is it? It's this guy, 0 minus x1. Looks like I have -2. Okay, so now we just simplify things. On top, 4 minus 1 is 3. On the bottom, since I have 2 negatives next to each other, 0 minus -2, these negatives cancel and I get +2. Hey, look, that's the slope that I already said just by looking at the line. Very nice. Let's do a couple more examples. Next example, find the slope of the line. Think to yourself, what's the slope of the line going to look like? Since my line is falling as I'm going from left to right, what kind of slope will that be? I should end up with a negative slope, and let's see why. If we choose 2 points on the line, let's do this one, and then we can just look for another one that seems accurate. How about this one? What's my rise and what's my run? Because remember, slope is rise over run. Okay, let's see. It looks like I'm going down by 4. Now, since I'm going down, I'm actually going to label this as a negative rise. My rise is -4 because I'm actually going down by 4. My run is just 1. And it's still +1 because I'm going to the right. Remember, the positive x's are to the right. So -4 over 1. And let's reduce that to just -4. Okay, nice. So there's my slope. I can also prove this by looking at the points and doing the equation. So let's look at what these points are. This point right here is, okay, let's see, 1, 2, 3, 4. It's over -4 up 1, 2, 3, 4, 5, 6. Let's call this the first point, x1, y1. This second point is over -3 up 2. And we'll call this x2 and y2. So remember, for my slope, by the way, did I mention that slope is labeled with an M? It's because mathematicians aren't always the brightest people in the world, and they call slope by weird letters. You would think slope would be S, but it's not. It's M. I just kind of imagine two guys, maybe they're at a party or whatever, and they discover slope, and they're like, what should we call this? And maybe they're not really thinking, or maybe they want to try to impress the girl that's next to them, and they're like, M, we'll call it M because we're hilarious. But this is why mathematicians don't normally make jokes, because calling M slope, not very funny. Anyway, we know that the formula for slope m is y2 minus y1 over x2 minus x1. And let's plug in y2 is 2, y1 is 6 over, let's see, x2 negative 3, x1 negative 4, so minus negative 4. Okie dokie, 2 minus 6 on top is negative 4. On the bottom I have negative 3 minus negative 4, that's negative 3 plus 4 because the negatives canceled. I have 1. Hey, look, that's also negative 4. It reduces. I was going to do this example, but this video is getting too long. We'll skip it. We'll do it at a later date. So, summary. Remember, slope, it's rise over run. Remember that a positive slope means a line that is going up. A negative slope means a line that is going down, a line that's falling. We didn't talk too much about this, save it for a future video, but zero slope is a horizontal line. And undefined slope, remember, this is the one that the guy would fall off because it is a vertical line. And here's the poor dead guy at the bottom. He fell off the undefined slope. Blah. All right, that's all for now. Sorry for the length of the video, but I hope that makes slope make sense to you. Bye.